right? Nope. You see it? All right, I think that's about as good as it's gonna get. All right, so the problem that we were asked to solve is that we are to find the absolute extrema of the function of x and y, which is x plus y minus x times y. We're supposed to find the absolute extrema of this function on the domain D, which is the enclosed triangular region from the three vertices, that being 0, 0, 0, 2, and 4, 0, giving us this right triangle sort of thing going on here. All right. Give me 1 second to write all this down. There we go. So that's the problem we're asked to solve. So find the absolute extrema. So to solve this, the first thing we can do is just try to find the critical point of the function in general, see if it falls within the region. So if we're to do that, we have to take the first order derivative with respect to x and with respect to y. Set both of those first order derivatives equal to 0 and solve for a value for x and y as our critical point. So to do that, just the first order derivative with respect to x is 1 minus y. For the first order derivative with respect to y will equal 1 minus x. We set these equal to 0, right? We are given y equals 1, yes. And for the first order derivative with respect to y equals 0, we're able to solve for x equals 1. As you can see there, because equals 0, just simple. All right, which then gives us the critical point 1, 1, which we will evaluate at the end and see if it is our absolute extrema or not. So that is just the critical point of the function. It does fall within the region, so we can evaluate that later, but we're going to try to find more critical points for this specific domain. To do that, we can look at this as having 3 sides, so that's what I'm going to do. So we have 3 sides to this triangle. Side 1 is going to be the vertical side, like the vertical line, like this, this side, you can see that, from the origin, right, to do I have 4, 0 up here? Am I dumb? I am dumb. Hold up. Okay, to 0. That was a mistake. Yeah, but this side will be side 1. We can represent this as x equals 0, as it is just a vertical line going through the origin. Side 2 is going to be from the origin 0, 0 to 4, 0, 0.40, which we can represent as y equals 0, as is a horizontal line just going through the origin. And then let's look at side 3. This one is going to be the slanted line, going from point 0, 2 to 4, 0. That one is going to take slightly more effort to find an expression for, but really not much. Since it's from point 0, 2 to 4, 0, it's pretty simple to find. Let's do y minus y naught xy. So 2 equals mx minus x naught, which will be 0 here. Expression for m will equal 0 minus 2 over 4 minus 0 minus half. Okay. Yes. So m equals minus 1/2. So y minus 2 equals x minus 0, which equal 2 minus. So our expression for this will, our m value would just be, the expression for this side will just be y equals 2 minus x over 2. All right. So now we need to find the critical points associated with each of these sides. with both sides 1 and 2 being horizontal or vertical line, it actually makes it really simple, because like the maximum spot, like the critical spots for those lines within this region is pretty simple. So we got the origin, and with this being the vertical line, it'll be a 0.02. Both of these are critical points for that side. For this side, side 2 being the horizontal line, once again, very simple, just be the origin and 0.40 as our critical points. And now side 3, we need to solve for the critical point here. To do that, we have our expression y equals 2 minus x over 2. Hold up, let me just make sure I got this right. Yeah, so what we can do is we can plug this y value into our initial function. 2 minus x over 2, which will, let me solve out for it actually real quick before I say anything more. This will give us the result of x plus 2 minus x over 2 minus 2x plus x squared over 2, which will simplify x squared over 2, it's going to be our biggest, plus 2 minus 3x over 2. Alright, so that'll, which we can actually just say this is a function of x, because it is only one variable now. That'll equal x squared over 2 minus 3x over 2 plus 2. Alright. Now to solve for the critical point on this third side, we need to, it's actually pretty simple, now it's just one variable. Take the first order derivative of this function of just x, which will equal x minus 3 over 2, that's it. We'll plug this into our equation, or of our expression of this side's line. No, we won't. That doesn't make sense. Hold up. Oh, that's right. Because I need to set this equal to 0, of course, and solve for x, because that's obviously what I should have done. So x minus 3 over 2 equals 0. That means that x just equals 3 over 2. So we'll plug that into our expression for the slanted line for side 3, which will tell me that y of x equals 2 minus 3 over 2, which should equal, hold up, 2 minus 3 over 4, 8 over 4. So 5 over 4 is a y value. So that'll then give us the critical point of 3 over 2, 5 over 4. And that's the only, yeah. Okay, and there's only one critical point for this third side. Yeah. Okay. So that's good. So what we'll do, we'll take all these critical points, 1, 2, 3, 4, 5, 6, but duplicate, so 5. So there's 5 critical points here. Crit points. So let's start with our origin. We have 1, 1, 0, 2, 4, 0, and 3 over 2, 5 over 4. All right, these are our critical points. What we will do is we will plug all these critical points into our first, our original expression, you know, the function of x and y. And these will yield the results that will allow us to figure out the absolute extrema of this domain, of this function in this domain. So at the origin at 0.00, we get 0, because 0 is all around. For 1, 1, we get 1 plus 1 equals 2, minus 1 times 1 equals 1. All right. For the 0.02, we are 0 plus 2 minus 0 times 2, which will just equal 2. For 4, it'd be 4 plus 0 minus 0 times 4. Yeah, so just 4. And for 3/2 and 5/4, we get 3/2 plus 5/4 minus 3/2, 5/4 equals, so we got 6/4. 8. So let's just double all these. We got 12/8 plus 10/8. Right? Minus 15/8, which will equal equals 7/8. All right. So, let's just do green here, I guess. Green, 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 green. Okay. So for all of our critical points, the highest value that returned is 4 zeros. This is going to be our max. Our minimum will be at the origin. So our absolute maximum for this function in this domain will be at point absolute max will equal 4 at 0.40. I'm gonna do absolute min will equal 0 at point of the origin, and this is going to be our absolute extrema of this expression in this domain. All right, that should be the answer. Let me zoom in just so you can see it a little better.